Okay, Mr. Reive here. So today I'm going to give you a tutorial on a Simon Says game using the Arduino or the LaunchPad, the TI LaunchPad, whichever. The code is the same. Here's an example of what it will look like. So you push any button to begin and then it starts flashing the sequence. You have to push the sequence in the right order back. You have 2 seconds in order to push the button, otherwise it will end the game on you. And if you get it wrong, as I will do in a minute, then the game will flash 5 times and it'll start over. There we go. Okay, so I'm actually going to use this website, 123dcircuits.io. I like this website. It does run a little slow as the code gets a little more complicated, but it's kind of nice that as I run, it'll run here on the breadboard. So I'm going to explain the code. This is the code here. There's a fair amount of code, but it's actually not as much as I initially had thought there was going to be. So I'm just going to take some time and explain some of the code. First of all, you should know that when I do run here in the simulator, it does run much slower than it actually does on the Arduino. Just to show you that, I'll show you. So upload and run. So you can see up here, this is the time, and it's roughly like maybe 5 times slower, even 10 times slower, because right there was about 1 second. But it does work fine. It's a little harder to play the game though. So right now what it's doing is it's doing flashing one light, second, yellow, blue, red, yellow, blue, waiting for a button to be pushed. Any button can be pushed at this time. As soon as you push a button, it'll wait a second and a half, and then it'll begin the sequence. So I have to push red, and then I have to push red, then green. So red, green. Then it'll play back the sequence. Every time it plays it back, it adds one. So it's a Simon Says game. So red, green, blue. So red, green, blue, red. And if you take too long or you get the sequence wrong, then it'll flash 5 times on you. So if I push green here, it flashes 5 times. 1, 2, 3, 4, 5. And then it goes back to the start sequence where it just shows the red, green, yellow, blue, waiting for inputs. Okay, so on to the code then. So it uses really 3 arrays here. The first array is the sequence, and I have it holding 100 long, and if you go over 100, well, I'm not exactly sure, I guess the game will crash. And it's very important to realize that all of the sequence is based on the position. So the way that we have it is this sequence will only ever store 0, 1, 2, or 3. And what that corresponds to is it corresponds to the other 2 arrays, which are the button pins and the LED pins. And so in those, there are 4 elements as well, and it goes in order here from right to left. So it's the red, this is the pin for the red LED, this is the pin for the green LED, this is the pin for the yellow LED, and the blue LED. And actually, let me just show you that on the Arduino. So here's a full view of the way it's wired. So the wiring here is pretty typical. Let me just talk about that for a minute before I continue actually. So we have the 4 output pins just going to the positive leg of the LED through resistor to ground. And make sure that you have a ground back to the Arduino. We also need, in this case, we have 4 buttons, and they're all being pulled down with a pull-down resistor of 10K. Make sure that you have 5 volts coming to the positive rail, because you're going to need that for the button input. So the way that it works, if you're not familiar with the pull-down resistors, or pull-down the buttons with the pull-down resistor, is when the button is being pushed, it will get 5 volts the input will get 5 volts. When it is not being pushed, there's no connection being made here, so it does not go to the 5 volts. But we don't want it to float high, so what we do is we put a pull-down resistor to ground. And so as soon as the button is released, then it's going to get a low signal. So if we do a button read, it'll get a low signal. But as soon as I push it down, the current will go through the path of least resistance, which is the 5 volts. You will have a little trickle off through the resistor, but it's negligible. And then if you do a button read, it'll give you a high. So when the button's pushed down, it'll be high. When the button's let up, it'll be low. Okay, so back to the code. This sequence then always has values of 0, 1, 2, and 3 in it. That's very important to remember. And if it's got a value of 0, for example, then that would mean that LED on pin 2 will show, which is red. And when we receive, when we're waiting for the buttons to be pushed, then that's going to be the 0th index of the button array, which is pin number 3. And so that's what you can see here. Pin number 3 goes to the red push button, and pin number 2, which is right here, goes to the red LED, and so on. So this is pin 5 goes to the green button, pin 4 goes to the green LED, and so on. The largest index. What I think I'll do is I'll explain the global variables. I have a bunch of helper methods, and then I'll talk about how the overall gameplay is played out. So this largest index, what it does is it keeps track of how many numbers are in the sequence currently. So when you start, there is none in the sequence, and as soon as you begin, it'll add 1 to the largest index, and there'll be 1. And every time you play back the sequence, it'll just keep adding 1 to the largest index. So it'll go 1, sequence will have 2, then 3, then 4, and so on, as long as you keep getting it correct. There are 3 states in this game, as you kind of could tell from the 2 demos that I've already played. There is a start state, which just flashes the LEDs one at a time, waiting for you to push a button. As soon as you push a button, you enter the play state. The play state, all that the play state does is it shows you the sequence and then waits for it to be played back. As long as you play it back in the correct order, you'll stay in the play state. As soon as you get it wrong or you don't push the button in time, it goes to the game over state. And the game over state, all it does is flash the lights 5 times and then exits. And then it goes back to the start state. The game never exits. It always just goes from the start to the play to the game over, and then back to the start, and then to the play and the game over, and so on. This game state variable just keeps track of which state that we are currently in, and the game state variable starts at the start state. Makes sense. Current mills and previous mills just keep track. While we're waiting for buttons to be pushed, we cannot do delays, because if we do delays, we can push the button as many times as we want, and we will never receive that input. So we always have to spin a loop and look at how much time has passed, and that's what these 2 variables are going to be used for. The setup just takes care of all the output LED pins and the input button pins. The neat thing is, now that we've set our pins up in these 2 arrays, we kind of never have to deal with the pins anymore. We always now can just deal with the buttons array and the LEDs array, and makes it really easy to set the pins up for input and output, as well as when we're receiving or when we're showing the buttons. So this is really nice. If we ever have to change the pin out, then we can change it right here, and we don't have to affect any other code. We do need this because we are doing pseudo-random generator. We have to do a random seed. If we don't do this, then it plays the same sequence every time we run, which isn't ideal. I'm not exactly sure if this matters, this analog read. I think it can be any pin. It just reads some garbage and then bases the pseudo-random generator on that garbage. And as long as the garbage is kind of always all over the place, and because we're doing an analog read, it kind of gets some kind of random number. and then it seems to work quite well. Okay, actually, maybe I'll talk about the loop. So this is the main game loop that's repeating. So remember, setup happens once. We do all our initialization, and then the loop happens after that. So in the loop, what we essentially do is we look at what state we're in, and then we do the appropriate thing. So if we're in the start state, all we do is we run this wait to start method that flashes the LEDs one at a time and waits for a button to be pushed. If we're in the play state, we are constantly doing this show the sequence, read the sequence. Okay, if they get that correct, we show them the sequence with one more, then we read it. As soon as they get something wrong, then we go to the game over sequence. Game over sequence just blinks all the lights on and off 5 times and goes back to the start sequence. So this is a fairly straightforward game loop. And so now let's take a look at, I guess, how the different states work. Let's start with the wait to start. So the wait to start is down here at the bottom. So this is the wait to start method. And so what we'll do is we just turn all the LEDs off, and then one at a time we go through each of the pins and we turn the LEDs on, wait for the button to be pushed, and then turn the LED off. Now we'll get to this method later. What this button wait does is it waits 800 milliseconds, and it tells you at the end of that 800 milliseconds which button was pressed. So if no button has been pressed at the end of that 800 milliseconds, then button pressed will be a -1. Otherwise, the wait for button actually will return as soon as a button's pushed with the button number that's being pushed, and it's not the pin, it's actually the position, which is a 0, 1, 2, or 3. Okay, so essentially what this game start does is it goes through all 4 LEDs waiting for a button to be pressed. As long as we're keep receiving -1 for the button pressed, then we just keep doing this over and over and over because we're in our start state. But this little bit of code here says if the button pressed is not -1, means that it's 0, 1, 2, or 3, then let the games begin, wait a half second, set the largest index to 0. This is just in case we've already played a game. We want to make sure that we reset it back to 0, and then make the game state go to the play state. Alright, and now what does the play state do? So coming back to the main loop, we take a look at the play state. So it looks very simple. We show the sequence, read the sequence. So let's start with show the sequence. Okay, so this is the show sequence. This is actually a fairly straightforward loop. All it has to do is go through the sequence array and show the LEDs that are in it. The very first thing that we do is we add 1 to it. So remember, largest index started at 0. So as soon as we run this for the first time, largest index is now going to be 1. And what we do is whatever the current largest index is, which is 0 when we begin, we set that array value to be a random value between 0 and 3 inclusive. So this 4 is not included. So the way that the random works is it will include the bottom number, but it will never include the top number. So this will give this command random 0, 4 will give 0, 1, 2, or 3. Okay, so that's which LED is going to show in the sequence first. Okay, now we say that there's 1 in the sequence, so we update it by 1. Then essentially we just go through the whole sequence one at a time. We're not reading any buttons at this point, so the user can actually push buttons. It actually doesn't matter. So that's why we're going to use the delay command. So what we do is we delay, turn the first LED corresponding to that sequence. So this sequence is going to have 0, 1, 2, or 3 in it. We feed that to the LEDs array, right? Remember, the LEDs array will be 0, 1, 2, or 3, but it'll give us the pin of the LED. So if we do the sequence, and then we look at which pin that it corresponds to, then we'll turn that pin on. We'll wait 700 milliseconds, and then we'll turn that pin off. And then we have to delay. We have to make sure that we have this quick delay here, 300, because if you ever have like the same LED on twice in a row, if you don't have this little delay here, it could have been after here, I guess, it doesn't really matter, then what happens is it looks like it's very hard for the user to tell because it doesn't flash in between. And so if it's, say the red is on twice in a row, it's confusing because the player thinks, is it on for a really long time or is it on for twice in a row? And sometimes it's even on 3 times in a row, and that makes it really hard. So what this will do is it'll make sure that when it's off, it'll kind of blink really quick, 300 millisecond blink, but at least then we can tell that that it's been off and that the sequence has, progressed in one by one. Okay, so that's all that does. It shows us the sequence, and so we're just sitting there watching it. Each LED takes roughly a second then, right? 300 milliseconds plus the 700 that it's on. Okay, so we're just sitting here waiting for the sequence to be shown, however many it is. And then if we take a look at our main loop, after we show the sequence, we read it. And so now let's take a look at read sequence. Okay, so read sequence isn't a whole lot long either, but there is a bit of magic in this wait for button. But right now we can just think of it as kind of like, we already discussed what it does. So just think about, how it works, and we'll get into the code after a little bit later. So read sequence, we have a couple local variables here. First of all, we want to know if we've made a mistake or not, and we're going to assume that, right from the get-go, make mistake is false, so we haven't made a mistake yet. And this position button, or position press, is just going to keep track of which button is pressed, so 0, 1, 2, or 3. So that's an index into the array. All this does then is, this for loop, it loops through, again, based on the largest index. So that could be 1, it could be 5, it could be 10. It just means it's going to keep looping through. And essentially what we do is, so let's pretend that we're going through this loop. If the index is 0, right, that's where it starts, then we sit here and we wait for the button to be pressed. And what this says is wait 2 seconds. If nothing has been pressed in 2 seconds, then this wait for button will return a -1, meaning nothing's been pressed. If, though, in this 2 seconds a button is pressed, then 0, 1, 2, or 3 will return immediately. So if, even though they're allowed 2 seconds, if they push it after 100 milliseconds, this wait for button will return in 100 milliseconds, and it will return the button that was pressed, but not the pin, but the position. This is handy because when you're playing back the Simon Says sequence, a lot of times you like to do it pretty quickly. So it would be really bad if we always had to wait 2 seconds, and we had to time it when we played it back. That would make the game really hard. Okay, so when we wait for this button, then this button press is either going to be -1, 0, 1, 2, or 3, and so then we take a look at what was pressed. If it's -1, then that means that they didn't press anything, but they were supposed to, so they made a mistake, and we changed states to the game over. So they're done. Okay, so now what do we really want to know? What we really want to know is this button pressed the same one that's in the sequence? So that's what this does here. So it doesn't look to see if it's the same, but it looks to see if it's not the same. So it says if the button pressed is not the one from the sequence at the index that we're currently reading. Remember, the index will go 0, 1, 2, 3. So if it's not the correct button that we should have pressed, then again, the game over. They've made a mistake, and we set the current state to the game over so that it'll flash. Now let's see how this make mistake flag works. Is say that in the sequence there's 10, but we make a mistake right on the very first one or the second one. Well, as soon as we set this game make mistake flag to true, well, this for loop says, start index at 0, keep going as long as it's less than the largest index. But it says, and as long as made a mistake is false. So as soon as make a mistake is true, this for loop will end, and we will go right to the game over state. And remember what the game over state will do. If we take a look at the main game loop, it'll blink all the lights on and off, and then it'll go back to the starting state. Okay, so let's just take a quick look at this blink all 5. What you pass here is how many times you want to blink all the lights on and off, and that's down here at the bottom. So I have a couple of helper methods. All off just turns all the pins off. All on turns all the pins on. Easy enough. And then blink all, and this tells you how many times. What I didn't do here is I didn't pass in like the amount of delay when you blink them on and off. So it always stays on for 300 milliseconds, off for 300 milliseconds. But it's pretty fast, and it looks pretty good when it's flashing. So yeah, we can tell whenever we call blink all, then we say 5, then it'll just go through this loop 5 times, and it just goes on, wait, off, wait, and then it does that 5 times. And that's how you know you're done. So it goes blink, 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 blink. It means we're done, and then it starts going to that wait sequence again. It starts showing the red, green, yellow, blue, waiting for a button to press. And as soon as you press the button, then the game will begin again. Now, there's one more method that we haven't talked about, and that is probably the most complicated method of the program, which is wait for button. So let's take a look here. Wait for button, it's a little bit more than a screen big. Maybe I can raise this a little, fit it all on the screen. Okay, perfect. So what wait for button, we already know what it does, like from a programming point of view, we know, but this is going to kind of be an explanation of how it works. So all wait for button does is it takes how long you want to wait for the button, right? If you don't wait that, if no button is pressed in that amount of time, then -1 will be returned. Otherwise, if a button is pressed, it will return the index of the button that was pushed, 0, 1, 2, or 3, and it'll stop this method immediately. Now, what we should know is, though, that this button doesn't have to just be pressed down, it actually has to be let back up. And the main reason I did that is because if you only trigger on when you press down, so say you're playing the game and you're supposed to do a red, then a green, what happens is when you press it down, it actually goes to the next one in the sequence immediately, and it reads the red one twice. And so it does a read, and then it says you're wrong, because it was supposed to be, for example, red, green. So what I had to do is I had to put a bit of code here to make sure that when I push it down, I let it up again before we look for the next one in the sequence, which would be the green, and again we push down, and then we have to let it up again. Okay, so here's how we do that then. Local variables, we have just which button was being pressed, right? We have the input, that's from the button read. We have just a flag to see if the button's been back up or not. So we can have the button being pushed, and if we're holding it down, then the button is being held down, so we know that a button is being pressed, but it hasn't been let back up again, so that can be very important. And then these are the global variables that we have, current mills and previous mills. And all this does is, this is going to be kind of like our clock kind of for us. So the current mills is always going to be however many milliseconds since the program started. And the previous mills, all that's going to do is we only record it once right now at the start of the method, and we're going to keep looking at the difference between previous mills and the current time, and to see how much time has elapsed, because our goal is to elapse for a delay amount of time. And so that's this code right here. So we take the current time, which is going to be larger than when we start it, that's what previous mills is, and as long as that's less than the delay, then we keep looping. Then we have and the button isn't back up yet. So we just keep looping here. So what do we do in our loop? Well, let's see. We have this for statement. It's quite a large for statement. I guess it goes to there. So this for statement essentially goes through each button one at a time and sees if it's being pressed or not. So if no buttons are being pressed, it's actually very quick, because it's just like all the buttons are low. So when it says, is the button high? It's like, nope. Okay. Is the next button high? Nope. And it just chugs through all the buttons really, really quickly. So it just spins this loop. It's only when a button is high, which is when it's pressed down, that this code is all activated. So let's take a look at what happens when the button is pressed then. So say any button's pressed. So, you know, whatever, we're always going from pin 0, 1, 2, 3. And remember, those are the indexes. They're not the button pins, but we actually have to go into the buttons array to get the pins. So we look then and we say, okay, say it's pin 0. You know, is pin 0 high? Well, yes, it is. Okay, well, if it is, then, well, let's record that then. Okay, so it was pin 0 that was high, so now we know that, because that's going to be needed to know if it's the right button in the sequence. But, and this is just kind of like to make the game a little bit better. It shows the whatever button you just pushed, it just flashes that LED on as you hold the button down. So it gives you a little bit of feedback while you're pushing the buttons. And now what it does, though, is it says, okay, as long as there's still time left in our delay and the button hasn't been let up, just keep spinning this loop. So the purpose of this whole loop right here is just to make sure that the button is let back up. That's all. So what do we do in this loop? Well, we just keep reading that same pin. Just read, read, read. And as long as it stays high, we actually don't do anything. We just keep reading. But we do look at to see how much time's elapsed. So it's like, we don't want the person to be able to hold down the button forever and just kind of pause the game. So we still need to kind of look at how much time's elapsed, because if, you know, our set amount of time elapses, then we do want them to say, ah, no, you held the button too long, you're done. So, so this whole time we're reading, then the input button, as it being held down, will be high. And just by the nature of a push, because when you push a button, even though it seems kind of instantaneous to us, this code is happening so quick, we probably get 5 or 10 or even more button reads. So this code will be activated almost every single time we trigger and play this game. So essentially what it does is it just says, okay, are you still high? Are you still high? Still high? And then eventually it'll be low. And it's like, oh, okay, you're low. The button is back up. And what that does then is it triggers this now to become false, because it says, is the button false? No, it's not. It's true. We just said it's true because the button was left back up, and we exit this while loop. Okay, as soon as we exit the while loop, then we turn the LED that they were holding off, so that, you know, there's our feedback. Now the feedback's off. But just in case they took too long here, we're going to check that. Now, if they took too long, then like when they started and the whatever the current time is greater than the delay, then we pass back a -1, and that indicates like no button was pushed. Even though a button was pushed, they pushed it and they held it too long. So we're going to end the game. But as long as this, as long as they did it within the amount of time, then this button pressed will be the same button that was pressed up here, like in our case button 0, and that's what will be passed back, and that's what this statement does here, return button pressed. So this, because this method here, most of the time when we have methods we have a void, the word void here, but because we have the word int here, that means that we're going to return a value, and what we return will be a -1, 0, 1, 2, or 3, and it will be whatever button is pressed, or right, or -1 if no button was pressed, and that's what this statement does right here. So we always have to have this return right before we finish the method. And now I think we've gone through all the code. So it turned out pretty good in the end. I guess the biggest headache that kind of took me longest to figure out was this, like when you push a button down, that we have to let it back up before we can continue reading the sequence. Once I figured that out, actually things went fairly straightforward. And because we use methods, the game loop is actually very, very nice and clean and very understandable. So once again, let's just have a quick game. We upload and run. So we're in our start sequence, but because the simulation is really slow, right, I'm just going to start the game. And so we have green. Let's see how well I can do. Green, yellow. Green, yellow, yellow. So you can see the yellow goes on twice. That's why it flickers, which is good. So now it goes on 3 times. So green, yellow, yellow, yellow. It's actually pretty fun to play. Green, yellow, 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 blue. Green, yellow, 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 blue, red. Green, yellow, 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 blue, red. Oh, I don't know. Getting too long for me. Alright, well, I hope you enjoyed this tutorial and have fun making Simon Says.